Students, I am R.B. Subsarai, lecturer, SMTT department. Now, here in this video, we will see a revision classes on second chapter determination of forces and power consumption. First question: with a neat sketch and explain forces acting on single point cutting tool during lathe operation. Here, in lathe operation, tool and workpiece, the force applied Px, Py and Pz and resultant force R. Here, the derivation is in any metal cutting operation, in a lathe, the resultant force R on the tool, therefore R can be revolved in three components Px, Py, Pz, which is shown in figure. The resultant force R is the force in horizontal plane perpendicular to the direction of feed Px. Px is the force in the horizontal plane against the direction of feed. Pz is the force in vertical perpendicular to the force Px and Py. The three forces depends upon essential characteristics. There are tool geometry depends upon essential characters. There are tool geometry, depth of cut, feed, work material, condition of working. The cutting force Pz can be expressed as follows: Pz is equal to Cp into T raised to x into S raised to y into K. Cp is coefficient, T is the depth of cut in mm, S is feed in mm per revolution, K is overall correlation factor whose values ranges from 0.9 to 1. The cutting force component Pz gives the turning moment of affected on workpiece. This can be found by using formula. Here turning moment Pz into R in Newton millimeter, mt is turning moment, R is radius of workpiece. The magnitude of bending moment is given by the expression mb is Pz into L in Newton millimeter. L is overhanging length of cutting tool. Power of the motor may be found of the following expression: Pm is Pz into V divided by 6120 into nu. V is equal to pi dn divided by 1000 meters per minute. Power consumption may be found out during cutting operations. Pc is equal to Pz into V divided by 60 into 102 in kilowatt. Pm is always greater than Pc. Explain the power capacity of machine tool. It's very important both to the designer and to the user. It's not advisable to use lower to the capacity or higher capacity of the motor. Then what is required? Let Nm is be the power capacity of the motor in full load and Nc be the power required for actual cutting. Nf be the power required for overcoming friction of machine element. Then Nm is equal to Nc into Nf. Nf is a Nf dash plus Nf double dash. Nf dash means what? Power to overcome frictionless when it is in off. Nf dash is power to overcome friction loss when cutter machine is on. First problem: the magnitude of force cutting on HSS single point cutting tool while machining MS bar of diameter 30 mm, depth of cut is 4.25 mm and feed is 0.52 mm per revolution. Find the turning moment affected on workpiece, bending moment working on horizontal plane, power of motor. Consumption of power is in cutting if the cutting speed is 25 meter per minute. The overhanging length of cutting tool is 35 mm and overall efficiency is 80%. Assume K is 0.835, Cp is 220, x is 1, y is 0.69. It's a problem. Solution. Given data, diameter is 30 mm, that is radius is 50 mm, thickness is 4.25 mm, Cp is 220 mm, x is 1, y is 0.69, efficiency 80%, that is 0.80, length is 35 mm, k is 0.835, v is 25 meter per minute, speed is 0.52 mm per revolution. Find Pz. Cutting force Pz is equal to, formula is Cp into T raised to x into S raised to y into k. Cp is 220 into T is 4.25, x is value is 1 into feed is 0.52, y raised to value is 0.69 into k is 0.835. That is Pz is equal to 497.2 Newton. Finding turning moment, mt is equal to Pz into r, that is 497.2 into 15, mt is 7458.15 Newton per mm. Finding mb, Pz into L, 497.2 into 35, mb is 17402 Newton per mm. Pm, Pz into V, 6120 into efficiency, 497.2 into 25 divided by 6120 into 80, that is 2530 watt. Cutting frequency Pc is Pz into V divided by 60 into 102, 497.2 into 25 divided by 60 into 102, that is 2031 watt. Therefore Pm is greater than Pc. Next question. Calculate the magnitude of force acting on single point cutting tool while machining MS bar of diameter 50 mm, depth of cut 2 mm, feed is 0.3 meter per revolution, the cutting speed is 583 mm per revolution, the cantilever length of the cutting tool is 40 mm and efficiency 85%. Assume k is equal to 1, Cp is 230, x is equal to 1 and y is equal to 0.8. Find the turning moment, bending moment, motor power of the motor, cutting power. Given data. Here diameter is 50 mm, means what, r is equal to 25 mm. Thickness 2 mm, feed 0.3 mm per revolution, length is 40 mm, efficiency is 85%, that is 0.85, k is 1, Cp is 230, x is equal to 1, y is equal to 0.8. Now v is equal to 583 mm per second is you have to convert to minute. 583 into 60 divided by 1000 is equal to 34.98 meter per minute. To find Pz, Cp into T raised to x into S raised to y into k. Cp is 230, thickness 2 raised to x is 1 into 0.3 feet, y raised to 0.8 into 1, that is Pz is equal to 175.57 Newton. Mt is Pz into r is equal to 175.57 into 25. Mt is equal to 4389.29 Newton per millimeter. Here Pm is Pz into V divided by 6120 into nu, that is 175.57 Pz is, and V is 34.98 divided by 6120 into 0.85, that is Pm is equal to 1.180 kilowatt is converted to 1180 watt. So Pm is greater than Pc. Next question, explain the sketch the forces acting on drill. Here the drilling Px, Py, Pz, the force applied. Here F is force is drill force is K into D raised to into S raised to M in Newton. D is the diameter of the drill. K is constant. S is feed. M is 0.74 mild steel. M is equal to 0.84 cast iron. For finding turning moment of the drill, following expression can be used. Mt is equal to kt into d raised to 1.9 into s raised to 0.8 Newton millimeter. Kt is constant turning moment. Here they determine the force required to drill cast iron work piece and also turning moment of the drill. The diameter of the drill 38 mm, feed 0.45 mm per revolution, and geometrical parameter for drill is K is equal to 58, KT is 30.3 and M is 0.8. For cast iron M is equal to 0.7 for mild steel. This one question. Given data is diameter is there 38 mm, speed is a 0.45 mm per revolution, K constant K is 58, KT turning 30.3 and M is 0.8 cast iron and M is 0.7 mild steel. First you have to find cast iron. Here Ci is equal to K into D raised to S raised to M. K is 58, diameter 38, feed is 0.45 raised to mild steel 0.8 for cast iron 0.8. So the answer is 1163.54 Newton. Next one mild steel FMS K into D raised to S raised to M. K is 58, diameter 38 into a feed is 0.45, 0.74 mild steel. So 1260.26 Newton. Turning moment MT KT into D raised to 1.9 into S raised to 0.8 is equal to 30.3 into 38 raised to 1.9 into 0.45 raised to 0.8. So the answer is 16,054.6 Newton mm. Next question. Explain with sketch the forces acting on milling cutter. Here the milling cutter is let diameter of the milling cutter and efficiency RPM milling cutter and depth of the milling cutter and width of the milling cutter and velocity of the cutter. So the average thickness of the chip, first you have to find average thickness of the chip. HM is equal to SM divided by N into Z square root of T divided by D. New efficiency is 1000 into V divided by pi into D in RPM. First question, milling problem. A job is made on milling machine. Milling cutter revolving at 48 RPM. If the diameter number of teeth on the cutter is 24, width of the cutter is 7 mm, feed per tooth is 0.3, feed 50 mm per minute, depth of the cut is 1.5 mm, diameter of the cutter 80 mm, variable x, y, z and q for steel 0.86, 0.74 plus 1, 0.86 respectively, while Cp is 60. Find the average thickness, chip and power consumption. The given data is new 48, 42 RPM, number of teeth 24, breadth is 12.7 mm and thickness 1.5, diameter is 80 mm, x is 0.86, y is 0.74, z is 1. First you have to find the thickness of the chip. The formula is HM is equal to SM divided by N into Z square root of T divided by D. SM is 50 divided by 42 into 24 into square root of 1.5 divided by 80. So the answer is 0.049 into 0.136 is equal to HM is 0.0067 mm. First finding the power consumption. N is equal to PT into V divided by 60 into 102. PT is equal to Cp into T raised to X into S raised to Y into Z into B square into D raised to 4. Pt is equal to 60 into 1.5 raised to 0.86 x into 0.3 into 0.74 into 24 into 12.7 raised to 1 into 180.86. Here Pt is equal to 4,60,608.35 Newton. Finding the velocity, efficiency nu is equal to 1000 into V divided by pi d. V is equal to pi d n divided by 6000. Pi diameter is 80 into efficiency is 42 divided by 1000. V is equal to 12.55 meter per minute, and that is n is equal to 4 lakh pt into V divided by 60 into 102. That is the answer is 794.02 kilowatt. Next question, find the power required for milling ms blank the following condition. The thickness is 2 mm, SM is 220 mm, width is 60 mm, hence E is energy 2.8 watt per mm cube, efficiency 0.75, diameter is 100 mm, N is 160 rpm. Find PC power. N is equal to E into B into T into S to M divided by 60 into 100 formula. That is substitute value, and N is 1144 watt. Cutting force PC is power divided by velocity. Velocity is pi into d into n divided by 60 into 1000. Pi into diameter 6000 into rpm 160 divided by 60 into 1000. That is V is equal to 0.83 meter per minute. PC is equal to 1.144 divided by 0.83, that is 1.37 kilowatt, that is 1370 watt. Finding torque T. First you have to find N. 2 pi nt to 60. T is a separated left side, N into 60 divided by 2 pi n. The answer is 0.69 kilowatt. T is 69 watt. Power of the motor PM. Power formula is power divided by efficiency, N divided by nu. N is 1.144 divided by 0.75, that is 1.5245 kilowatt. That is PM is 1525 watts. That is PM is greater than PC. Thank you for this complete unit.